Hi guys, in this video I will show you how I fixed a broken nut with a FreeCAD and a 3D printer. So I have this stand for a Dremel. It is just a retracting pole with a hook. So I will show you what it is. So yeah, this is a pole, retracting pole with a hook where a Dremel can be hooked. And a locking nut that is locking the final hook was broken. So I designed it in FreeCAD, printed it, and it worked just like the original one. Here is the picture of the final result. So I will show you the process, how I designed it. So I will use a standard version of FreeCAD. It is the latest version, and one thing that the developers did in the latest version, they removed the image workbench that was previously used to trace a picture. So currently this functionality from the image workbench is moved to the core of FreeCAD. So I will show you how it is done in the new version of FreeCAD. So let's create a new document, and now I will import an image. So here is our picture. So it is already on the XY plane, and now we need to scale it to the right dimensions. To do this, I need a single measurement that was taken from this part. So I measured with a caliper distance from this side to this side. To scale it in the new version, we do it just by double-clicking the image, and it opens this dialog, and we can use this interactive scale. So we align it, zoom as much as possible to be as precise as possible. Click interactive and click the first point here and the second point here, and enter 14 millimeters that we measured before. Yeah, I did something wrong. Let's do it again. Yeah, first point, second point, 14 millimeters, and I need to click accept. Yes, right. Now it is scaled to the right dimensions. Another thing that I need this part to be centered along y-axis. To do this, I need to move it a bit, but it's not, because right now it's not in the center. I can do it later when I start tracing the nut, and it will give me some references so I can position it more precisely. So start with a part design workbench, create a body, create a sketch, XY plane, and now I will start tracing our part, a profile for the revolve operation. So we'll go with multi-line. I will do this line first. Actually, I don't need multi-line right now. And I will do the opposite side as well. It's temporary. I need this just to position the image in the center of y-axis. To do this I will create those symmetric, and here also symmetry. So I will position it like this, so I aligned it along one edge, and it is clear that our image is not centered. So I can close it for now, and yeah, I don't see the sketch because the sketch and the image, they are both on the same plane, so I can actually bring our image a bit down. It's enough, so I can so our sketch on top of the image. And now I can position more precisely along x-axis, so I can move it. So more or less in the center. I can adjust the sketch to follow the profile. Yeah, I think it is good enough. Yeah, it is good enough. Okay, so image centered, and we can proceed with our profile for the revolve operation. So right now we are just tracing this profile by eye. So I think the height is correct. So I want this conical shape to be a bit taller than the mating part, so it can squeeze this plastic part, and this plastic part will squeeze the rod. So I think the height is correct. Let it be like this, and dimension, horizontal dimension is also fine, and we can constrain this horizontal dimension, and we will proceed with the rest of the part with multi-line. So I would need this extra horizontal line, and need this vertical line, and we'll trace the outer shape of our nut. Okay, so I need this and need this to be parallel. It's not strictly needed, but it's good to have those parallel. And I need so the next point is how to position this. There are actually two approaches to model a thread. One way is to add material, and another is to remove material. I think removing material is more natural because it is how it's done in the real life while machining the part. So we are removing material with some tool. So we'll do the same process here. So we position this to be like big enough to cover those teeth, but not as deep as to cover it completely. So I think we need some clearance here, so like this is enough, is correct. So we constrain this horizontally, let it be 6.01, and we will define the thickness. It can be 3 millimeters. It's not strict dimension. And we need height of this part. It can be 10 millimeters. And now we have our sketch fully constrained. And we can do a revolve operation. Yeah. Okay. So we have our base shape of our nut. And next we need to create a thread. To create a thread, we need to trace a single teeth and use subtractive helix to cut the thread. But we also need to know the pitch of the thread. To find this pitch of the thread, we need to measure the distance between the teeth. So we can actually do it in a new sketch, XY plane, and we can measure distance between number of threads. So we just use a simple line and position it like this, and we measure it like this. So it gives us 5.95, so it's close to 6. And as 6 we have 1, 2, 3 teeth, and we divide 6 by 3 and have like 2 millimeters thread pitch. So it's okay, we know it, and now we can proceed with tracing a tooth. So we go with multi-line as usual and start tracing a tooth. We need it to be a bit bigger, so we have some clearance between a knot and this thread. We're just doing it but by eye. We can adjust it later if we don't have enough clearance or the clearance is too much. So we'll give some constraints. This should be equal, and this one can be like this. Don't need it. We don't have the dimensions. We are just measuring what dimensions we receive by tracing the image. Let it be like this, and this one. So we're just locking the dimensions, and we also need to lock a vertical dimension. Okay, so now I think we have it almost fully constrained. We only have 1 degree of freedom is along y-axis, and we need to position it a bit outside of our part so we can have a clear entering of the thread. So we can use actually this, our previous sketch, to reference it. We can have those aligned, those points aligned. Okay, so we have the profile for the thread, and we will cut a thread with this profile using subtractive helix. So we can hide the previous sketch and try using subtractive helix. So it gives some errors, but we can ignore them. And we measured the pitch to be exactly 2 millimeters. And see what is going on. You see, we here have some space between threads, and we need it here because in the standard version of FreeCAD, subtractive helix cannot be self-intersecting. I did it in the Rio Thunder fork of FreeCAD, and there subtractive helix can be self-intersecting and it produces a valid body. But in the standard version we need to make sure that those single threads are not intersecting. Okay, so the next part is figure out how deep our thread should go in. So I think we had like 10 millimeters that dimension. We can hide our image and see 10 millimeters is just up to this face. Okay, and see if we have a valid body. Yes, we have. So the base shape of the knot with the thread is ready, and the final step, we need to add some ridges along the outer the cylindrical part, so it's easier to grip on this knot, just like in the original knot we have some protruding pieces, so it's easier to turn it. So let's proceed with it. Create a new sketch, XY plane. No, not XY plane. XZ plane. And we need the outer circle as a reference. And we need an arc. I need, I think, 3-point arc. Yeah, like this. And I want the center to be on the axis. And fit radius 1 millimeter. So it's more or less okay. Just lock this position, and we need to close it. So we need a closed contour. So we use another arc with the center in the origin, and those ends are connected. and for some reason we lost this constraint, so we just repeat it. Yeah, I know why it disappeared, because we have auto remove redundant constraints and it happened to be redundant. Okay, so we have fully constrained sketch and we can pad it, and we can pad it up to face and select this face. So a single part, this part is ready, and we can make a polar pattern of it. Something wrong, because I think I selected not the right part to helix. Yeah, now is correct. So I think 12 should be enough. Yeah. Okay. So we have our locking nut, and we can check how it sits on our image. We can use a clipping plane. I think Z, we can flip it. Yeah. You see, it's not aligned on the thread. But it gives us a rough idea how it will sit on our this rod. Okay, I think that's it. So I can show one more time. This is part that I designed and printed with a 3D printer, and it works just like the original one. Okay, thank you for attention and have a great day. Bye.